Potential due to system of charge. Okay, I will give you some hacks. Just remember the formulas. Okay, just remember the formula. That's it. Let's move to this thing. Our next topic is potential due to system of charge. Okay, then just consider an example. We have a triangle. We have a triangle. On that triangle, on that triangle, just remember this thing. What I am saying, I just told for the system of charges. We have a triangle. This is triangle. We'll do namkaran. Q1, yes. Q2, yes. Q3, Q1, Q2, Q1, Q3, Q2, Q3. The distance between Q1 and Q2, Q1 and Q2, it will be what? It will be R21. Yes, you can write R12 also. No problem. What is Q1, Q3? The distance between Q1 Q3 can be represented by what? Anyone? Anyone? Yes. R13. Good. What is the distance between 2, 3? R23. Okay. Now. You have to find potential due to system of charge. Now, we'll see. I will give you some hacks. I'll give you some hacks. Yes. Do not worry when I am here. Okay. Now, the formula for potential energy will be equal to pair of charges. Pair of charges. Some bonuses are remaining. Don't worry. I'll give you some more details, some more tricks on this. But just remember, the potential energy in the system of charges will be the pair of charges. Potential energy will be equal to pair of charges. Now, that means, see, individually potential energy can be represented by U. So U of system will be equal to U13 plus U23 plus U12. Every point 1 3 2 3 1 2 or 2 1 as your wish. We have done the namkaran. You can write it anything. You can also write R1, R2, R3 all upon U. Okay, now we know the formula for potential energy. It's K QQ over R. KQQ over R. That means here it will be K. What is K? Yes, the birth constant. Very good. Very good. It will be Q1. It will be Q3 over what? It will be over R13 plus K. What is 23? This will be Q2 Q3 over R23 plus. Yes, I am not getting space. This formula is big now. That's why I'm writing on this. Do not worry. Then third is K Q1 Q2 over what? R12. Okay, this is the formula for finding the system of charge. This is the formula to find the system of charge. Okay, now one more example. What if instead of triangle there is a square or rectangle? Let's see. We have 4 points. Done with the story of triangle. Story ends here. Yes, I know it is feeling incomplete. Do not worry. Just think of the formula. In this question, in this type, only numericals are expected, not the derivation. Only numerical or MCQs are expected, not the derivation part. Okay. So here, what we have 4 charges. We'll name it as 1, Q2, Q3, Q4. I'll join this square. Okay. There are how many pairs? Anyone? How many pairs? See here there were three pairs, and as there were three pairs, na we found three potential energy. Here how many pairs? Anyone? How many pairs? Here how many pairs are there? Four pairs. One, two, three, four. We are considering this as pair Q1, Q2, Q2, Q3, Q1, Q4. You are considering these as pairs. If you are thinking that answer is 4, you are wrong. Why? Why? I check the diagonal. Check the diagonal. Even this Q2 will have influence on Q4. Even this Q1 will have influence on, say, yes, Q3. Okay, okay, okay. Now, so there are how many pairs? There are, yes, ladies and gentlemen, there are 6 pairs. As there are 6 pairs, so how many potential energy we can find? We can find 6 potential energy. Yes, that's why I gave this Namkaran. You can write this as R12. You can write this as R23. You can write this as R34. You can write this as R14. Bacha, you can write this as R13. You can write this as, say, yes, R24. So with the help of these things, what you can find? You can easily find what? You can easily find your potential energy. How many pairs are there? 6 pairs. Okay, now, heck, a trick, a trick. It's secret. Yes, it's secret. Okay, trick. Tricks are number of pairs is equal to n minus 1 over 2. Number of pairs. How many number of pairs? If you are getting confused by giving the answer as 4, that's why I know that you people will have the problem. That's why this is a trick. It's a secret. Number of pairs will be equal to what? This will be equal to n minus 1 over 2. How many charges here? 1, 2, 3, right? That means this is 3. 3 into 2 will be 6. 6 over 2 will be 3. Are hai na? We have what we have? We have 3 potential energy. 3 pairs, 3 potential energy. Okay? Acha? This was ittifaq? No. This was not an ittifaq. This was not a coincidence. This will act everywhere. See, check here, check here, check here. How many charges we have? 1, 2, 3, 4. Yes, 1, 2, 3, 4. Yes. So in place of n, what you can write? 4 4 into, yes, 3 over 2. 2 ones are 2 twos are 3 twos are what? 6. Hence, this is not an ittifaq. This is not a coincidence. It will act everywhere. Okay, thanks, me later. Okay. Then we'll see some numericals based on this. Okay, you got the things in textbook. The things are given in very details. The notations which they are using, I am okay with it, but there should be a separate namkaran for everything. Okay. Now what? Now what? Now we are going to see. We are going to see few numericals. based on this. You people are going to just give me the. You people are going to give me the answer for this. The question is, I'll give you the question. The question is, there are system of charges. The question is, I'm not going to solve this question. I'm just giving you the question. In next session, you are going to give me the answer of this question. I'm just giving you the question. Just use your i11 processor. Yes, the latest one, i11 processor, and let me know the answer. Okay, then what? We have the question. We have the question. No chat GPT, no Google will be accepted. Okay, I want the solution in my style. Yes. So the first thing, the question is, in this question you have two charges. Yes, one is positive, named as 3 into 10 raised to minus 8 coulomb. Another one is negative, named as minus 2 into 10 raised to minus 8 coulomb. Okay, and then we are, this is 3 into 10 raised to 8, this is minus 2 into 10 raised to 8. These two charges are separated by distance of 15 centimeter, by distance of 15 centimeter. Then by 15 centimeter. Now what we have to find, we have to find the point. This is our Garuda, it's the villain. I have to bring this villain somewhere such that their potential, its potential should be 0. So where I can bring this villain? Potential should be 0. I want to bring this somewhere where its potential should be 0. How it will be possible? I repeat the question. Question is, we have two charges. 3 into 10 raised to minus 8, minus 2 into 10 raised to minus 8. We have villain somewhere outside our system. We have to bring this villain inside such that the potential on this will be 0. So potential is 0. Let's consider that our villain is somewhere here. Our villain is somewhere here at point P. Okay, here potential is 0. That means I'll say over there V1 plus V2. At P, potential will be 0. Let's consider this is at some point P where our potential is 0. What is V1? Yes, KQ over R. What is R? KQ over R. This is K. What is Q? 3 into 10 raised to minus 8 over V. Let us consider this distance as X. So this will be what? This will be 15 minus X. So this will be equal to KQ over R. That means KQ over X plus, yes, K into, what is Q? Yes, Q is minus 2 into 10 raised to minus 8 over, what is R? R is 15 minus X. Now what? Now I will write 3 into 10 raised to minus 8 into K over X is equal to minus 2 into 10 raised to minus 8 into K upon 15 minus X. Okay. k minus 8 will get cancelled. What you will get, you'll get this is minus 2, this is minus. After going to the other side of equal to sign, it will be positive. So therefore this will be equal to 15 minus x over x is equal to 2 over 3. So therefore this will be 3. 15 minus x is equal to 2x. Therefore 45 minus 3x will be equal to 2x. Therefore 45 is equal to 2 plus 3 will be 5x. Therefore x will be equal to what? 5 nines are 45. So how much we have to displace this charge? This charge should be displaced at a 9 centimeter from this point, and what, 6 centimeter from this point. Okay, then I hope I had cleared the question. This question I was supposed to give you as a homework, but then I thought let me help with my student. Let me help to my student how to find this type of question. This acha, even this is not necessary that this will lie between this point. It can be here also. You can try for trial and error. I'll give you one more hint. The hint is if the answer is negative, avoid that answer. Okay. Yeah, if this answer would be negative, I would have avoided this answer. I would have considered that this is somewhere here. I would have considered this is the distance something x, and this will be this complete distance minus 15. And I would have found the answer, and if that answer would be positive, I would have considered that same thing. Okay, so in TBSE there are the chances of asking this tricky questions.